Hi, I'm Maury Rosenthal, and in this video I'm going to show you how to modify the hand controller for a Questar telescope. That's a controller for the PowerGuide II 9-volt DC system, so that the telescope can be used for long exposure astrophotography by adding a guide camera. The first step is to open the hand controller. We're going to take out the 9-volt battery and unscrew the screws holding the controller together to get at the printed circuit board so that we can start the modifications. Next, we're going to remove the 3 small Phillips head screws that hold the printed circuit board in the case. The point of this modification is to add a 6-pin modular jack to the hand controller, soldered to the key connections to make it operate properly. You might be able to source one of these jacks in different ways. I find that the jack from this Radio Shack modular phone jack works well. Now, again, you need to make sure that you get the 6-pin version, and the terminology is a little bit jumbled. It can be listed as RJ11, RJ14, or RJ25, but all of those convey the 6-wire lead that we need to use for this. So we're going to open the jack, as I've done here, and now remove this component. It simply slides out. Now we'll screw it from the contacts, and then trim the wires to prepare it to be soldered into the case. If you use the same jack, you can follow the colors as I describe them as we complete the modification. But just in case you source a jack from someplace else, you do need to pay attention to the position of the different wires, make sure that you're connecting them properly. So the wires are coded in positions 1 through 6, and in a moment I'll go through them carefully. But what we're going to do first is remove the number 1 wire, which is the white wire in this case, and then trim the ends of the leads, the remaining leads, to prepare them for soldering. Let me show you the sequence of the leads and how that matches the colors here. Obviously, the way that you hold the jack impacts the way that you would count them off. I'm pointing with the screwdriver to the first lead, the first contact, which was for the white wire that we've already trimmed away. The second contact is for the black wire, and that's an important one that's going to be the ground or common. Here at the end, the 6th wire is the blue wire, which in this case will be connecting to the west switch. So the sequence, once again, is white, trimmed away, not used, 2 black for ground, 3 red for east, 4 green for north, 5 yellow for south, and 6 is blue for west. Now, by matching up the PC board against the case, we can see which button is which. The top white button is the north, bottom, with my finger on it's the south, and then the left and right ones are the east and west. Now, each button is attached to the board with 4 contacts. 2 of those contacts are ground, and the other 2 are the active side. Now, we need to connect one lead, the black lead, to the ground somewhere on the board, and here I'm using a continuity tester to determine that these bottom 2 contacts on the south button are attached to the ground, and I can also confirm that the top 2 contacts are are on the active side and only are connected when the button is depressed. So I'd recommend that if you can use a continuity tester to make sure which leads are which, that will avoid problems as we make the connections. So we're now going to begin soldering the leads corresponding to the buttons to the PC board. Now, I know from having done this before that the jack will fit nicely if we actually solder in some of the wires on one side and the others on the other side of the PC board. So with the buttons facing down, here I've shown the attachment of the yellow and the green leads to the proper contacts for the north and south buttons. And now I've turned over the board, and the red is already attached to the east button, and I'm going to solder this blue wire to the proper contact on the west button. And with that, it'll be complete. So just to review one more time, here we see the blue connected to the west switch and red connected to east, and on the flip side of the board, black for the common on the ground side of the south switch, yellow on the active side of the south switch, and above the integrated circuit here you see the green soldered to the north switch. Alright, now we can test the fit of the board back into the case, and we're going to want to make a notch in the case to fit the jack so that it fits snugly and doesn't flop around. Okay, so I'm going to use this Dremel tool for this purpose, and let me just mark a couple of little notches. Okay, so that should give me a pretty good idea of where I'm cutting. And let's cut this down. So we snap this part out, and we'll clean up the plastic with other heads from the Dremel in a moment, but we check the fit, and now let's cut into the other side of the case. I'm using a sanding attachment on the Dremel to just very carefully and gently trim down the board and now smooth out the edges around the cut. Okay, so we're ready to reassemble the device. And there's this plastic end. I'm going to put on here and drop this all into place. Circuit board is back in place. I want to replace the top of the case without And the battery leads, bring them out to make sure they're safe. Okay, and we'll add the battery. So with the battery back in place, the modification is complete, and now the device is ready to be reattached to the mount for testing. I hope this has been helpful. For more information about guided imaging with a Questar telescope, you can see my notes in the Cloudy Nights or Yahoo Group's Questar forums.